for next week. You have everybody back. Right? Okay, this is not going to be on the test for next week, but this will be on the next test after that.
Okay.
So it's not like we just get to ignore it, but it will not be on the test next week.
Okay.
But points and lines is where we are going to start. So you guys probably have done this before, and it'll be a little bit of review. So looking at the first one, we want to talk about a graph. A graph is simply a picture of the solutions to an equation. So when we draw like a line, all those points on that line are points that make some equation true. Yeah.
In the test, will you ask the question?
No,
like that?
I will not ask you to define things. Thank you for asking that. I don't ask you to define terms, but when I talk about a graph, I need you to know what I'm talking about. So that's why I put it in there for you. Okay? It's a picture, so we can visually see what's going on. The plane, which is where we draw our graph, the plane is divided into 4 sections by the horizontal axis, which is the x-axis, and then the vertical axis, which is the y-axis. So it's going to look like this, and you can see them on your paper already. But here's your horizontal axis. Oops. Here's our horizontal axis, the x-axis, and then we've got our vertical axis, which is the y-axis.
Why?
So it has these 4 different sections, right? That makes sense? Did the air kick in? Everybody's all of a sudden like, I'm freezing to death. I'm like, I'm so happy because it's not hot. Okay. Where the 2 lines meet. So in other words, this point right here is called the origin.
Origin.
The origin.
Origin.
Okay?
Origin.
It's like where everything starts. So it's everything is, and so that's the ordered pair. It's when x is 0 and y is 0. Okay? And we'll talk about this, but this is the ordered pair 0, 0. And we'll talk about this, but the first number is the x and the second number is the y when we do that. You remember that?
Almost forgot.
You almost forgot it? Okay. And we're going to be doing a lot of that today. So you're going to get refreshed in your memory. Okay? So let's find the coordinates of each of these. Now, if you haven't done these for a while, just as a reminder, again, this is the x-axis. Here's the y-axis. These are the positive x values over here to the right, because 0 and it acts like a number line, positive over here. These are the negative values over here to the left. And then when I look at the up and down, I think of like a thermometer. So the positive values are up towards the top, and the negative values are down below the 0. Okay? We don't typically have to deal with below 0 down here in Missouri, but we did a few times last winter. I was really surprised. Like, hey, this hasn't happened for a long time. Well, since I had been here. In Minnesota, it's below 0 all the time. Not
You're
all the
from
time.
Minnesota?
Yeah.
Oh, nice.
So
So
I-
why are you here?
I won't say it's all the time below 0, but it gets below 0 during the winter
Why Missouri?
frequently. It's a long story.
Well,
Well, I don't have time to tell it right now. I don't have time to tell it right now. So you want to know why I got to Missouri from Minnesota, but you don't want to know why I went to Singapore? I mean, what? Okay.
It's just crazy whenever people say that they come from another place to Missouri. It's just like, why Missouri?
Okay. So let's start with A. Here's how we find the coordinates
1, 2,
for
3,
point A.
4.
We are going to count left and right first. So from 0,
Okay,
going-
Sally.
we're going over 1 space to the right.
That's 1.
Okay? So that means our first coordinate is 1, because we went from 0, 1 space to the right.
Okay.
Okay? Then, after we've counted the left and right, we count up and down. So this is going up. How far?
4.
4. So 1, 4 is the coordinates. Those are the coordinates for point A. Okay? So we always do left and right first, because those are the x's, and they go first. And the y's always come second, and that's the up and down. Okay? So let's do B. So we're going to go, let me do a different color here. We're going to go left and right. So we're going to go to the left. And hopefully you can see it on your paper, even if you can't see it up here. How far are we going?
-5.
-5. So point B, -5 first. That tells us we're going to the left 5 spaces. Then we're going up 3 So what number do we put in for the y?
3.
Yes, 3. And that tells us from the origin, we went to the left 5 and up 3. Okay. And how about point C? Let's do point C. Point C, we're going to the right one. How do we represent that?
1.
Positive 1, comma. And then we're going, oh, no, we're not. Sorry.
No, we're not. Oh,
I got my lines mixed up there. Okay,
Oh.
forget that.
Sorry. Me
I
too.
was like,
Forget that.
wait.
Notice we're not going left and right at all. We're just going straight down, correct? So what are we going to
0.
put in for the x?
0.
0, because we're not going left and right. I didn't realize until I was going to draw the line down and I was going to miss the dot. Okay,
I was like, well, I guess I'm gonna go
Wait.
like that.
curvy line here.
Block that you go down is going to be 0?
No, the reason the first one is 0 is because we didn't go left and right. Or maybe yes, I'm not sure. I'm not sure that I understood your question, but since we didn't go left and right at all, that's the first number. So how far did we go left and right? 0. We didn't go left and right. We just stayed. Now-
Goes down is negative.
We're going to go down 2. So that's going to be -2. Okay. Does that make sense? So yeah, don't mess up your eyes and then you run the wrong line or something. So, but anyway, any point that we want to find on this coordinate plane has coordinates that would match up to that one point. Okay. Does that make sense?
What did you say?
Any point that we've got, like I could put a point here, I could put a point here, or
Uh-huh.
over here, or wherever. Any point that I put on there, we can find the one set of coordinates that matches up to
Okay.
that one point.
Okay. Yeah.
Okay?
Yep.
All right. Are we okay on that? Do we want to make some more, or are we okay with finding those?
Okay. I am.
Well, we're going to get more practice as we go on anyway. Like these, where we have to draw them. Oh, no. And we're going to draw them one at a time. Okay? One at a time. So let's start with point A. 3, 2. We always start from the origin. So right here's the origin. From the origin, where am I going to go to get to point A? What does this 3 tell me?
Going to the right.
3 to the right. So I'm going to go over 3 to the right. Okay, and then what does this 2 tell me?
Going up.
Positive or
Up 2. Okay, so the first one is always left and right. The second one is always up and down. So up 2. So this point right here is point A. The ordered pair, the coordinate is 3, 2. We call it an ordered pair because they have to be in the right order. The x has to be first and the y has to be second. So it's an ordered pair of numbers. All right, let's go with B. -2, 1. What does the -2 tell us?
You're going to go down
to,
to.
to the left.
Remember, first is left and right.
X to the left.
So we're going to go to the left 2. And then the 1 tells us
Up.
Up 1. So here is point B. All right. Are we okay so far? Point C. 3, -4. So again, we start with the first one. What does the 3 tell us?
To the right.
To the right 3. And then what does the -4 tell us?
Down.
Down 4. So here is point C. Is everybody okay with those first 3? Okay, so take a couple minutes, try the last 4 on your own, and then we'll go over them quickly. Maybe you haven't done already, I'm not sure, but try those last 4 on your own and see how you do. I'm going to erase the first 3 so I can reuse my colors. All right, so I'm going to go with D. D says -2, -3. That means we're going to go 2 to the left and down 3. So this is where point D is going to go. So you can check yours if you've done that already. Point E, -3, 0. That means 3 to the left.
Zero.
And then 0 up and down, so it just stays right there. So that is E. Does that make sense? The zeros are either going to stay on one of the two lines, either the up and down line or the left and right line. All right, what's next? F. Go with purple. This one says 0, 2. So that means 0 left and right and up 2. So that's just going to go straight up to here. That looks really close to black. It's supposed to be purple. Does it look black to you guys or not?
Yeah,
Okay.
it looked black.
All right. And I know I'm going blind here, but anyway. And then G is 0, 0.
Just in the middle.
Oh, I didn't label the F. Yeah, 0, 0 tells us it's going to be where? It's not moving at all. It's moving 0 left and right and 0 up and down. So what I use? Red. It's going to be the origin. That's correct. That is G. Okay, how do we do? You okay?
Good.
If we didn't get it, do we understand now? Any questions? All right. So what we're going to do now is graph some lines.
That's where it confused. Well, I just need a.
So here's what we're going to do to begin with. Remember, this line, this equation, has a bunch of points that is going to make it true. And when we draw those points, we're going to be able to draw those points that make the equation true. We're going to be able to draw a line that goes through the points. So here's what I'm going to say we're going to do. One option that we have is we're going to make what I call a T-chart. So X and Y. Okay? And we can pretty much pick whatever values for X that we want. Remember, X is called the, oh, actually, we haven't talked about that in this class. Never mind. But we can pick whatever values we want to for X. It's actually, we'll talk about this later, but it's called the independent variable. We can pick whatever we want, but I would pick things that are on the graph, right? You could pick 300, but it's hard to graph that, okay? So let's pick things that are relatively small, like maybe -2 and -1 and 0 and 1 and 2. You don't even always have to do 5, but I'm going to pick these 5, okay? Now here's what we do. Remember how we did substitution the first week and we had to plug in the numbers in place of the letters? Well, that's what we're going to do. We've got y equals -2 times x plus 3. And I'm telling you for this first one, we're going to replace the x with a -2. Now, when we do that and we simplify, you do your multiplication first. What is -2 times -2?
Positive 12.
Positive 4. So this becomes 4 plus 3, and that is 7. Now, that's too big. It doesn't fit on my graph, right? So I'm not going to worry about that. I just won't graph that one.
Okay.
But I'm going to go down to the next one. I'm going to do the same thing. Y equals -2 times something plus 3, and I'm going to put in a -1 in place of the x. And again, that's just because I picked -1. So what is -2 times -1?
Positive 2.
2, and then plus 3 gives us
5.
5. Okay, so this one, that order pair, -1, 5, I can put that on the graph, right? -1 means 1 to the left, and then down 5. Oh, wait, sorry,
No,
up 5.
up
It's a
5.
positive 5, so 1 to the left and up 5. So -1, 5, that's going to be this point right here. That's one of the points. Let's try 0. Zeros are usually pretty easy. Again, I'm replacing the x with a 0. -2 times 0 is
0.
0 plus 3.
3.
So 0, 3. So 0 left and right, and then up 3, going to be right there. Now let's try the 1. I'm replacing the x with a 1. And -2 times 1 is?
-2.
-2. And then plus 3
1.
is 1. So 1 comma 1. So that means 1 to the right and up 1. Okay, and really once we have 3 points, we have enough. I mean, even 2 points is enough to draw a line, but I like to draw a few so we make sure that we're getting a nice straight line. So let's do the 2. Y equals -2 times the 2 plus 3. And -2 times 2 is?
-4.
-4 plus 3, -1. So our last point that I'm going to do is +2 comma -1. 1, 2 to the right and down 1. Do we see how we're getting a straight line there?
Mm-hmm.
Okay. So, and there's even a pattern to this line, isn't there? Down 2 and to the right 1, down 2 and to the right 1, down 2 and to the right 1. So I could probably guess those would be the next 2 points, right? If I kept going, that's just going to help me draw my line. Now, fortunately for you guys, when you do this on the computer, you just put 2 points on there, and then there's a tool that draws the line through those 2 points, and you don't even have to make it straight. It does it automatically.
Good, because I
didn't do too bad on that one. Some of my lines get really crooked. That one's not too bad. So does that make sense? How we can do that with the T-chart? Okay. She looks nervous.
No, it's just when you're picking the numbers, that makes me nervous.
Yeah, you can pick whatever.
Whatever.
I usually just pick numbers close to 0 because they're
I was
small.
gonna say, is that
Yep.
safe to do that?
That's pretty safe.
Okay.
There are some times where I might pick some a little bit different, and I'll try, if we have an example like that, I'll try and show
So
you.
you have to have both negative and positive? Or do you-
Not
does it
necessarily,
matter?
but I like to get a
Makes
variety,
sense,
but
okay.
yeah. Okay, now the next one is a little bit different because the y isn't by itself already. So you remember how I was saying, you would do this because you're going to have to redo the same steps over and over to solve. This is one of those situations. If I make a T-chart and I pick X values and I plug them in here, do you see how we're going to have to do steps every time to get the y by itself to solve for y? So this would be one of those examples where, like in section 1.5, where we might try to get the y by itself first
before we
start picking our numbers.
Okay.
Or before we start plugging them in, at least. I mean, we can pick our numbers whenever.
Okay.
So let's think about that. How can we get this y by itself? What would be the first thing we would do
Divide by first.
before that?
minus
Because the
2
3 is grouped with the y, right?
minus 2x.
Does that make sense? What's grouped with the y? The -3? Does that make sense? The -3 is grouped with the y? So we would get rid of the outer layer
-2x.
first. And we would do what with the 2x? Subtract?
Mm.
Yep. It's a positive to cancel it out. We're going to subtract it. So we have -3y equals 6 minus 2x. And then what else would we have to do?
Divided by -3.
Divided by -3. And I think I'm just going to leave it like that because we're just going to get numbers and put them in anyway. So even though I wouldn't normally leave the negative down there, for now, it doesn't really matter because we're just trying to find numbers. So what sort of numbers do you guys want to pick this time? So this is our new equation. Y equals 6 minus 2x divided by -3.
So you can just do 1, 2, 3, and then
I would pick 0. Zero is nice a lot.
0, 1, 2, 3, and negative.
And why don't we start with these, and if we think we need more, we'll add more.
Okay.
Because like I said, as long as you have at least 3, you're probably in pretty good shape.
Okay.
Okay, but if we start getting ugly numbers and want to choose different ones, we can do that too. So if we put in a 1, y equals 6 minus 2 times that x value over -3, and I'm putting in a 1.
Why we choose Y instead of X? Is there any?
Well, here's why. Because normally when we're picking letters, or picking numbers, I mean, we pick the x values.
Mhm.
And so
So
we
you want
almost always solve for the y if we're going to do that. You could solve for the x, and then you'd want to pick y values then. But usually we don't do that just because more frequently our equations have the y by themselves.
got it. Thank you.
Okay, so this is 2 times 1 is
2.
2, and 6 minus 2 is 4 over negative 3, and that's negative 1 1/3. So not ideal, but we can probably graph that fairly easily. So 1 comma, 1 to the right, and then down 1 1/3, about right there. But I'm kind of having to guess, right? That makes sense? All right, let's go to the next one. Y equals 6 minus 2 times something over negative 3, and this time we're putting in
2.
the 2. So we're going to have 6 minus, oh, we can do this in our heads. What's 2 times 2? 4, and then 6 minus 4
2.
is 2, and it's over negative 3, so negative 2/3. So negative 2/3. Again, not super nice, but we can graph it. 2, and then down 2/3, which is about right there.
Oh.
Okay. Next one. 6 minus 2 times, and this time we're putting in a 3. So 2 times 3 is 6, and then 6 minus 6, 0. So 0 divided by negative 3 is just 0. So 3 to the right and 0 up and down. That's really good because it looks like it's making a straight line. We like that. If it starts making curvy lines right now, you probably did something wrong. Should be for today, we should have straight lines. And let's put in the 0. Y equals 6 minus 2 times a 0 this time over negative 3. And 2 times 0 is 0. 6 minus 0. 6 over negative 3 gives us negative 2. So 0, negative 2. And does it look like all of our lines are going in a straight line? Or sorry, all of our points are going in a straight line?
Yeah.
Yeah, so we can probably be fairly confident that this is where our line is. And again, on the computer, you'll just select 2 of your points and draw a line through it. What I would say on the computer when you're doing your homework, try and get points like these where you don't have fractions, because it's really hard to graph the fractions very accurately enough that the computer will say, yeah, you've got the right answer. Okay, because it's going to be trying to find exact values. So
What is a tip for that? Like what? How can
a
we?
tip, okay.
I kind
So
of want to say I remember, but I don't remember exactly what it was.
yeah, and it depends. In this sort of a situation, there's not a great option. If we did some more simplifying, then you could tell. But in this case, because your denominator is 3, well, like I say, it's more complicated than just this. But if you look at the denominator being a 3 and you notice which ones worked, 3 worked and 0 worked, because in this case, multiples of 3, like 6 would have made a nice number, and negative 3 would have made a nice number. But you just have to kind of look at the pattern, and the pattern is they were 3 apart from each other, and so any 3 you would go in this case. I mean, if you sometimes you'll have like every other one will work, or maybe every 4th one, or whatever. So it just kind of depends. You just have to kind of test it out. Try to get at least 2 that are nice, and then the calculator will usually, or the computer, I mean, will usually agree with you. All right, done with that one. Any questions? Should I go back? Any questions before I erase this? All right. Everybody's like, what just happened? We were just grabbing points, and then all of a sudden lines appeared.
Yeah, I was happy for a second.
All right. So that is, now your assignment, you'll notice, okay, so assignments, you're going to need to do 1-5, which is the one we did at the beginning, and 1-6, okay? And then those are homework assignments, those are required. The review for the test, that's optional. That's for practice for you, but I will give you some extra credit for it, okay? So do it if you want to. If you don't want to do it, that's totally up to you. Then you will do 2-1 and 2-2. They're grouped together as one assignment, though. Okay, so it's just going to look like one assignment.
Okay.
Because the problems are grouped together. All right. So let's do this one. So we're going to keep talking about lines. This section 2.2 is still about lines. Okay, so what we were graphing just a minute or two ago, we're going to be talking more specifically about why do the lines look like this? Okay, so the first topic we want to consider is what is called slope. And I messed that up. What you're supposed to be seeing is not this. You're supposed to be seeing this right now. Slope is a measure of the steepness of a line. So in other words, how quickly it goes up or how quickly it goes down as it moves from right to left, or sorry, left to right. Okay, now we have a little formula or some words to help us remember what slope is. And usually we go, slope is rise over run. Rise meaning this changes, and then the run meaning left and right changes also. Okay, now the way we think about that in graph terms, it's the change in the y, how far it's going up and down, divided by the change in the x, how far it's going left and right. Okay, so just to give you a couple quick examples. It is possible that I have a line that goes, let me just freehand it here, that I have a line that goes from this point up 4 and over 1. That's a fairly steep line, isn't it? It's going up pretty quickly. It's possible that I could have a similar line that goes up 4, but over 7. Now, this one's slope was 4 over 1. This one's slope is 4 over 7. They're both going up the same distance, right? But one is only going over 1 to the right, and one is going over 7 to the right. So what does it do to the steepness of our line? It's a lot more gradual, right? It's less steep. Okay? So the bigger your slope, the more steep your line is. Okay? Yeah, if you had one that was like 100, it would be practically going straight up and down. Okay? And we're going to get into that as we go on. So let's take a look at this one. Identify the slope of the line. Now, when I do this, again, this is just a hint that I think makes this easier. Always go from left to right, just like we read in English and we read in Spanish. In other languages, I know they don't always go from left to right, but we're just going to pretend we all go from left to right. Okay? So we're going to start with this point, and we're going to go to this point. So this is going to be our first point. This is going to be our second point. Okay? Now, first of all, we're doing our up and down stuff. To get from here to here, we obviously have to go down, right? So we're just going to go down this far. How far down are we going?
1, 2, 3, 4.
And we write, since it's going down, we write -4. Down 4 spaces. Does that make sense?
A little bit.
You start here, down 1, down 2, down 3,
Oh.
down 4.
Yeah.
Okay?
Are you sleeping?
Don't count the dot as the first point. Were you thinking it should be 5?
I stopped at the line.
Oh, you stopped here.
Yeah.
Yeah, we got to get down to this
Right,
point, so we
right.
want to go down 4.
Yeah.
Then we're going this way. And how far are we going that way? Well, 1, 2, 3, 4, 5, 6. So our slope is change in y, -4, divided by change in x, which is 6.
What?
What?
Changing.
Change in y, that's the up and down, over the change in x. And if you go from left to right, your change in x is always positive, which is why I like to do it that way, because that way that's always positive. And the only one that could be positive or negative is this one right here. Okay? Now, it's a fraction, -4 over 6, but we don't like to leave it as -4 over 6 because it can be reduced. What can we reduce -4 over 6 to be?
2/3.
Yeah, -2 over 3. Okay, and so that's what we would write for our answer. Now look at this picture. Again, you can see it on your paper. But notice there's another exact point that we see right here, isn't it?
Mm-hmm.
And look at what that one does. Down 2 over 3. Okay, so you can actually pick any 2 points to do this. Now I showed you 2 points to kind of emphasize these are the 2 points that are exact, but if you can find another exact one, and sometimes they don't even give you any points, you just have to find some exact points. If I went from here to here, down 2 over 3, right? It doesn't matter what 2 points you choose, but I would choose them as wisely as possible. Try and choose exact numbers so that it's really easy to just count.
So, in an example, they won't give you like the dots,
Sometimes they might not.
and you just have to find.
You just have to find ones where it goes exactly through these corners like this. Like this one I wouldn't pick because it doesnes go through a corner.
Okay.
This one I wouldn't pick. So you want to
And
find
that's
ones
the
that go
slope.
exactly through the corner.
Okay.
Because then you can just count. Okay, does that make sense? How we did that one? All right, let's try this one. And again, I'm going to go from left to right. I did put the dots on here for us. So this is going to be my first point, starting on the left, and this is going to be my second point, going to the right. So the first thing I'm going to do is change in X, or sorry, change in Y, up and down. So I'm going up to here. How far up are we going?
Can we do like that way,
6. Can you do what?
the other way?
From here to here?
No, from the second point to the first point.
Yeah.
Can we do like that?
Yes, but I'm going to show you why I would suggest not to, but yes, you can. I think it's more difficult, but yes, you can. So if we start here, we go up 6 and we go over how far?
3.
3. So we've got 6 over 3, which can be reduced to be what?
Half. 2 by 1, 2.
Yeah, 2. Now, as a fraction, 2 is what?
2 by
2 over 1. It's 2 over 1. So when you're thinking slope, you probably want to think about it this way, but we would never write it that way. We would write it 2. And if you look at this again, if we go up 2 and over 1, you see there's another point, and up 2 and over 1, and there's another point, and up 2 and over 1, and there's another point. Okay? Now, to answer your question, Sally,
I got it now.
you understand?
Yeah.
Okay. If you go this way here, and just so everybody knows, if you go this way, what's going to happen is you're going down.
Down,
So down 6.
down 6.
And you have to remember that this is backwards to the
-3.
left, so that's a -3. So -6 divided by -3 is still
2.
+2. But that's why I say I don't like to mess with the left and right backwards direction. So I always go from left to right, so that one's always a positive. And this one going up was a positive. So, but you will get the same answer. I just think it's a little bit trickier to keep track of. Now, the other thing to remember is if you look back at your first line, as you were going from left to right, it looked like it was going downhill, right? Correct?
Mm-hmm.
That's why it's a negative slope. If it's going downhill like that, you should get a negative slope every time.
No.
Notice this one, from left to right, it's going uphill. That is a positive slope. Okay? Does that make sense? She's doing a little slope dance right here.
So that I can. It's too much information.
It's too much. All right, now how about these two?
Says the girl that finished all the.
Overachiever.
Now look at this one. If we talk about the up and down first, what would you say to me? Up and down. To get from this point to this point. Is it going up and down at all?
Great.
So the up and down part is 0, isn't it? And then the left and right? 3. And what is 0 divided by 3?
0.
0. So the slope here is 0. Now what does that mean? So if you think about that, a slope of
Just
0
steady.
means it's a horizontal line.
Just keep going.
It's not changing.
It doesn't keep going.
It's horizontal. It's not changing at all. It's just going straight left and right. Okay? So it's not positive going uphill, and it's not negative going downhill. It's just flat.
What is that called? Nothing.
Well, it's a slope of 0. Eventually, we're going to learn it's called a constant because it's just never changing. It's always the same. The y value is always the same. This is, when you think about these y values, y is 2, 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 and so on. So, I mean, we haven't talked about that name yet, but
How can we know which one is X and which one is Y there?
x is always left and right, and y is always up and down.
So let me think about this.
So
that
this,
is one.
what?
Where is the origin?
Right here.
So I'm confused now.
So like this point right here would be 1, 2 to the left,
So
So
minus
negative
3.
2, comma, and then up 2 be negative 2, 2. This point would be 1, because 1 to the right, and then up 2.
Okay.
And notice no matter what point you choose, the x values are different, but the y value is always 2, right? Because this one would be like negative 5, 2, or negative 6, whatever. But they're always something 2. 10, 2, 3, 2.
And how is it become 0 by 3?
Because it's
The slope? Because what's the up and down? What's the change in y?
so you would try to do like
So to get from this point to this point, if you try to go up or down, you're not going to get to this point because it doesn't go up or down.
Okay.
It just goes straight across. So you're
that is 0.
that part is 0 and this part is 3, and so you have the 0 divided by 3. Remember how this one on the previous slide?
I saw this one on an X, not on a Y.
Say that again.
Yeah, that line I just see like that's on a X exit instead of Y exit. I see like that.
You mean the axis? It's
Yeah,
where it's touching this is the y axis?
I didn't see
Because the
Y.
x, and this may be confused. The x axis does go horizontally like this, and this line goes horizontally. Is that what you're saying? Because it looks like the x axis down here. It's just
I think
higher.
she's confused with the slope, going from one point to this point. That is where I think she's. maybe.
Is that what it is?
We don't
Let's come back to this because we're going to get a formula in about a second that's going to kind of explain this. I think. If it doesn't, we'll come back to it. Okay. So that one is a slope of 0, horizontal line.
mhm.
Now notice this one. What's the up and down change this time? We can't really go left to right, but
5,
we're going up 5. How far are we going left to right?
0.
0. So we've got 5 divided by 0. Do you remember anything about 5 divided by 0? Or anything divided by 0?
0?
It's not 0.
You know,
Oh.
You actually can't do it. It's undefined. I don't remember. You have to remember I teach 4 classes during the day, so I forget
That
sometimes
must be hard.
what I've talked about to certain classes. But you cannot divide by 0. If you try to do that in your calculator, 5 divided by 0, it will give you some sort of error message because you can't do it. It's what we say, it's undefined. It has no meaning. It's like, here's a pizza divided into 0 pieces. Does that make any sense? No, because if you have a pizza, there's at least 1 piece, right? You can't make it into 0 pieces and still have a pizza there.
If it's the other way around.
Yeah, if you have that still is a little weird to think about. 0, no pizza divided into whatever. But anyway, so what we say about this slope is 0. This slope we say is undefined. Undefined.
That's going to be confusing.
Yeah,
And you have to.
The basis.
Yep. And so it's undefined, and it's because the bottom is going to be a 0. Now, here's our summary of that, and I think that's on your paper. But all horizontal lines, that was like this first one there. Horizontal, do we understand that word horizontal? Know what it means? Horizontal? Like the horizon in the sky, you're looking off the horizon, it's this horizontal, okay? Those always have a slope of 0. Then your vertical lines always have a slope that is undefined. Always. So if you ever know the slope is 0, you know it's a horizontal line. If you ever see a slope that's undefined, you know it's a vertical line. Okay.
so all the time when we see a vertical line, it has an undefined.
Undefined, every time. If you ever see a horizontal line, you know automatically the slope is 0.
So maybe we don't have our problems with that.
Well, we probably will. So again, our definition, and we added another piece to our definition, right? We already said this, change in y divided by change in x. We already said rise over run. But here's when we get to points. When we're thinking about those coordinates, here's our definition using coordinates, our formula for this slope. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And the subscripts just tell you second point, first point. So in other words, it's the second y coordinate minus the first y coordinate divided by the second x coordinate minus the first x coordinate. And that's what the rest of this saying for a line that goes through these points, xy for point number 1 and xy for point number 2.
Okay.
And we're going to do examples, okay? Because it's really not hard. It's just a way to remember. It's really just a way to remember which ones you're dealing with.
I'm just glad this is not gonna be in the
You
test
should
for next
stop
week.
here. I'm
We're gonna-
worried that I'm so confused.
Have to finish the lesson. All right.
Okay, just stop. In the
Just
middle.
stop in the middle. Just finish it on your own.
Finish your own. We'll come back with your answer.
Not over here.
Okay, so I'm going to rewrite the equation, right? Y2 minus, and it's just on your paper, but I'm going to rewrite it back up here. Y2 minus
Good
Y1
job.
over X2 minus X1.
Mhm.
And when we look at this, here's the thing. It doesn't matter which one is point number 1 and which one is point number 2. You're going to get the same answer either way. So we just need to pick one of them to be point number 1 and one of them to be point number 2. If I have a choice, what I usually do is I look at the y values, or no, sorry, I look at the x values, and whichever one has the bigger x value, I make that point number 2.
Okay.
And I'll show you why in a second.
So that will be easy.
So let's say this is the second point, and this is the first point. And the reason is because this 2 is bigger than the negative 4.
You said the X, right?
I look at the x. Okay, now it doesn't matter. There's no right or wrong. It's just, I think this makes it easier. So let's plug these in. So that means if this is the second point, this is x sub 2. This is x sub 1. Does that make sense? Second point, x sub 2. First point, x sub 1. Which means this is what?
Y1,
Y sub 1. And this is
Y2.
y sub 2. So then we just plug them into our formula.
How do you say it? Y sub?
It's subscript. So it's an abbreviation. If you say y1 and y2, I'll know what you mean. I
Okay.
say y1 and y2 sometimes as well. So putting this into our fraction, y subscript 2 is negative 9 minus y subscript 1 is 3. Everybody okay with that so far?
Okay.
And then here on the bottom, x subscript 2 is the 2 minus x subscript 1 is the negative 4. And before I do any math, I want to make sure everybody understands where those numbers came from. Okay?
From the problems.
Now the 2, notice what goes on the top, it's the 2 y values. And what goes on the bottom is the 2 x values. Always. Okay? So you're always going to have one from each set of parentheses on the top and one from each set of parentheses on the bottom.
And you're subtracting this end because
That's the
the
formula.
formula.
You're always going to subtract. Okay? Now, help me out here. Negative 9 minus 3. And if you want to use your calculator, that's fine. It's negative 12. And on the bottom, 2 minus negative 4. Now, remember what happens when we subtract a negative number?
You add
We
it.
get our calculator and it does it for us.
You add it.
If you remember back, this is from 2 weeks ago,
You choose it.
you add the opposite.
6.
So it ends up being 2 plus 4 becomes a 6. This is why I always put the bigger number first on the bottom, is because then that bottom number will always turn out to be positive. And remember how I said we don't like negatives in the denominator? So that's this way you won't ever have a negative in the denominator. If you do it the other way, you'll still get the same answer. You just have an extra step to simplify. All right, so what is negative 12 divided by 6?
2.
Negative 2. And our slope is negative 2 for the line that goes through those 2 points. Okay.
So we're gonna get to the point where we have to find the points and we have to.
Well, you'll either, no, not usually.
Oh, okay.
You'll either be given the points or something.
Okay.
Okay, so same formula. We're not changing the formula.
Okay.
All right.
You said you picked the.
And I
biggest
usually pick the bigger one to be 0.2, bigger x value. So which one would I choose this time?
4.
The 4. I would choose this one, the bigger x value, to be x2, which means the other x value is x1. And once I choose that, this has to be my second point, and this has to be my first point. So that means this is y1 and y2.
So it's 6.
And again, if you don't choose it that way, it's not a big deal. If you always want to make the first one, and the next one, the second one, that's fine too. It'll still work out. So according to our formula, y2 could be 6 minus y1, -1. And on the bottom, 4 minus 2. Okay. So yeah, we're going to change this because we want to add the opposite. And it does make it into 7. And on the bottom, 4 minus 2, 2. We do not want to change our slope typically to be a mixed number. Just leave it as a fraction. Because remember what this tells us? We're going to go up 7 and to the right 2. If we're drawing our picture. Up 7 to the right 2.
So how come in the last one, 12/6 is -2?
Yeah, we just reduce. I mean, you always reduce your fraction if you can.
But
But this one doesn't reduce. So like I wouldn't make it 3.5.
Oh, that, okay.
Does that make sense?
Yeah.
I want to leave it as a fraction. If it's going to be a fraction, I want to leave it as just something divided by something. Okay. Does that make sense? All right, let's try another one. All right. So notice what happens here when I try to pick which one goes first. They're both the same. So it doesn't matter which one goes first. So I'm just going to put this one. So first and second. So that means this is x1, y1. This is x2, y2. So we're going to have y2, -5, minus y1, -1. And on the bottom, x2, -4, minus x2, -4. Now, when that happens and those x's are the same, look at what happens to the bottom. What does that turn into?
0.
0. Right? You're going to be adding -4 plus 4 turns into 0. Right? Now, the top, I'll go ahead and do this. It's -4. But again, what happens when we try to do -4 divided by 0?
Undefined.
Undefined. So this is undefined. Now, what does that mean about the line?
It's gonna go vertical.
It's a vertical line. Remember, all undefined slopes mean vertical line. So if you think about what this picture looks like, it would be, I'll just quickly draw it. 1, 2, 3, 4, down 1, and 1, 2, 3, 4, and down 5. So it's this vertical line going straight up and down like that. I mean, if you draw it, you're going to see it's vertical, but just knowing the slope is undefined tells you also it's vertical. Okay. How about this one? Which one would I pick first? And again, you guys pick whatever. Which one do you want to be first?
3.
3. So first and second, that means this is x1, y1. This is x2, y2. So looking at our fraction, what goes on the top?
1.
1 minus
1.
1. And on the bottom?
-2.
-2 minus 3.
Mhm.
So on the top we get 0. On the bottom we get -5. Now again, this is why I would pick this one to be point number 2, because I like to have my bottom numbers to be positive. But it doesn't matter. You just have to simplify it. And in this case, it's really easy because what's 0 divided by -5?
0.
0. So our slope is 0. What does that tell us about the line?
Vertical. I mean horizontal.
It's horizontal. It's not, and what does that mean? It's not going up and down at all. It's just going straight to the left and right. So those two are the special cases, the zeros and the undefineds, because those are either vertical or horizontal lines. Okay. Does that make sense? And actually, very quickly here to go back, Sally, when we talk about this one, if you think about those ordered pairs again, this was -2, 2. This was 1, 2. When we use that formula, it's going to give us 2 minus 2 on the top. which is going to make it a slope of 0.
Mhm.
Because that's talking about how much is it changing this way? It's not changing at all. So there's a 0 there, and then just the x's are
So
changing.
y is 0 and x is.
The change in y is 0, and the change in x is 3. And so that's what you would get with that formula too, whether you're counting it on the graph or whether you're using the equation. Okay, so we've seen that. We got through these examples. Let me get there again. Okay, so example 130. This book never resets. I wonder how many examples. Are we going to get like 1,000 examples or something? I don't know. Chapter 2, and we're already on example 130. Okay. Now this question is a little bit different, right? This question says, find the value of y so that the line between the points here and here has a slope equal to -3. Okay, so here's the difference. This time we know what the slope is going to equal already. We're missing one coordinate. Okay, so which one do you want to be 0.1 and which one do you want to be 0.2?
5,
This is 0.1 or 0.2?
0.1.
0.1, okay. So this is x2 and x and y2, and this is, no, I labeled that wrong. Okay, this is x1 and y1, first point. This is x2 and y2. So on the top, we're going to have y minus -1, right? y2 minus y1. On the bottom, we're going to have x2 minus x1. That makes sense? Now, on the top, what do we do when we subtract these negatives? Yeah, so it turns into y plus 1 over 2 minus 5. -3. Now notice this is an equation, isn't it? We've got a variable here that we're trying to figure out. So we've got to go back to chapter 1, equation land. And if we're trying to get this y by itself, what would we get rid of first?
-3.
The negative, because remember,
There.
this y plus 1 is kind of grouped together by that division bar. That division bar groups it. So we've got to get rid of that -3 first. How do we do that?
Times -3.
Multiply, that's right. Multiply by -3. And if we multiply on the left, we got to multiply on the right also. So cancel, cancel. Y plus 1 equals, what is -3 times -3?
9.
-6.
Positive.
Oh.
That's adding. We need to multiply.
Oh,
9.
Positive 9, right?
Yeah.
And then one more step to get this y by itself. What
Minus
are we going to
1.
do? Subtract 1. So y equals 8. Okay, and if we went back and we looked at this and you got 8, 8 plus 1 on the top is 9. We already know -3 is on the bottom. And do we see that that's going to work out? That's -3. So our answer is, for this to work, we need y to be 8. Right here.
you are recording this.
Yeah.
So
So watch it again.
the only thing I'm confused is on the 9.
This was, I was just checking it to show you that it worked.
How did you check it?
So we got the y equals 8. So we went right back up here and said, okay, let's check it. If y
Okay.
is an 8, we're going to have 8 plus 1, which
Okay.
gives us 9.
9.
And then on the bottom, we already had 2 minus 5, which is
Negative
-3. And then we're just dividing 9 divided by -3 does equal the -3. And so that's what it's supposed to equal.
Okay.
So we're just checking to make sure it worked out to give us the right slope. Okay, and I think we've got one more, right?
Yes.
This time we're going to find the x value to make this work instead of the y value. But it's going to be basically the same. So the first question I have is, well, with one difference, what
X.
do we want to be the first point and what do we want to be the second point?
X the first point.
X is the first point. Okay, so first, second. So that means this is x1 and y1, and this is x2 and y2.
And the formula is
And our
y.
formula says y2 minus y1, so 2 minus 6. And on the bottom, x2, negative 3, minus x1, x. And what is our slope supposed to equal?
2/5.
2/5. They gave us that. They have to, otherwise we can't do it. Okay. Now, again, there are different ways to do this. So the way we've talked about, I think there are easier ways, but the way we've talked about, I don't want to try and throw all sorts of stuff at you, but the way we've talked about is we don't want this x to be in the denominator, right? We can't solve for it when it's in the denominator. So do you remember what we did to take care of that problem earlier tonight? How we got the x out of the denominator? Since it's dividing by it,
Multiply.
we multiply by negative 3 minus x on this side and then on this side. So cancel, cancel. And actually, let's go ahead and simplify that. Does that make sense? It's negative 4. Right here, 2 minus 6 is the negative 4.
Okay, yeah.
Okay, and now we just have an equation, and our goal is to get this x by itself. So what would you try to do next?
Divide? No.
Distribute.
There's actually a couple options. I don't think I would distribute again because let's leave this grouped and let's just try and get rid of this stuff. You could distribute.
Okay.
It's just going to make fractions all over the place.
Okay.
So I'd
No, I don't
rather
want
not do that.
Uh,
So, and I know on the equations we did distribute, right?
Yeah.
And then we got rid of the exponent. But there's a little bit easier way to do it in this particular case. Again, I don't really like the fraction, so how can I get rid of this fraction? Multiply by what? By a 5. A 5 will cancel out the bottom 5, right? So we multiply by 5 and 5. Notice that'll cancel. Right? They're dividing by 5. We multiply by 5. So this gives us negative 20 equals 2 times negative 3 minus x. Now, if we want to get rid of the 2, what do?
Divide with 2.
Divide by the 2, because they're multiplying. So now we don't need the parentheses anymore. We just got negative 3 minus x and negative 10. We actually do the division. What else do we need to get rid of?
Plus 3.
Yeah, we need to add 3. So this cancels a negative. The negative is still there with the x. And then this is negative 7. And then how do we finish this up?
Divided by negative 1.
Divide by negative 1. So we get x equals 7. I know some of you probably can't see that because other people are in the way, but x equals 7. And if we plug that back in and checked it out, we should get that. Yes, that would make the slope equal 2/5. Okay. Now just a little hint here again. I just let you guys choose. I think it would be easier, especially when you're solving for variables, which you don't have tons of problems like this, but if you're ever solving for the variable, make sure that one goes in the front. So I would choose this to be point number 2 so that the x is in the front. That way you wouldn't have to worry about the negative minus x at the end. It's not going to change a ton, but it'll make it a little bit easier.
I might multiply across.
And that's yeah, you can use proportions, but we haven't talked about proportions. So I didn't just want to pull that out of thin air and say, oh, we can do proportions. And you're like, what are proportions? We will get to that eventually. But yes, if you know about proportions and you wanted to cross multiply, it's called cross multiplying, you could have done that at the beginning too. So
No, Sally. No.
Really, just get out of this class.
just kidding.
I'm
Okay.
sorry, Sally.
So that's the end of that one. The videos, I will get them posted
Today?
as soon as I can. But sorry, that's the end of that one. And so, like I said, section 2.1 and 2.2 are together. There's only 9 problems between those two because it's, you know, finding those points and drawing some lines and then some slope stuff. So, and I've got probably a relatively equal number of those. I'm not even sure if I have any like this last one. I can't remember for sure. I
Yeah,
think
this one was a little confusing.
I think it's mostly just use the formula to find the slope.